Smallpox is a deadly disease contracted from person to person that affected people's lives all over the world for many years. Tragically, it killed many, but recently it was eradicated, resulting in a triumph. Although millions of fatalities resulted from the smallpox epidemic, it helped shape modern vaccines and medicines to keep us healthy today.
Smallpox can easily be described as being one of the deadliest diseases that humans have ever come in contact with. A combination of torturous symptoms, grotesque deformities, and a detachment from society can make a victim feel as though they were no longer who they were. It is mainly contracted within public spaces through moisture in the air when an infected person speaks, coughs, sneezes, or spits. The first week or two of smallpox was known as the incubation period. During this time frame, the virus grew in the lymph nodes, spleen, bone marrow, white blood cells, and small blood vessels, basically taking over the body and preparing to attack bodily functions. After this, the patient would develop an astounding 100 to 105-degree fever, followed by severe back pain, crushing headaches, and an unbearable abdominal pain, which brought constant vomiting. This is also when you would see the infamous spots that give smallpox its name, known as pustules in the medical field. In 3 to 4 days after all symptoms are present, they lessen in severity and slowly become more tolerable. Smallpox can be extremely deadly, with a death rate of about 1 in 3 cases. These deaths mainly occurred within the first week or so of the virus, believed to be because of large amounts of the virus in the bloodstream and the failure of the immune system's inflammatory response. Once the system has been flushed of all things smallpox related, the survivor must deal with a new obstacle, the deformities that ensued after the fact. Scarring of the face, arms, legs, stomach, and back were the most common deformities, but some cases reported the loss of the lips, nose, ear tissue, and even blindness if the eye was scarred at the cornea. Over 300 million lives have been taken during the heart-wrenching 3,000 plus years that smallpox has infected our planet, before officially being eradicated in 1980. Smallpox spread throughout cities and villages like wildfire, mainly because people had no idea that they had it until they were symptomatic. Even victims who were vaccinated against smallpox still sometimes contracted the virus, so it spread to an average 2 to 5 people for each case. Smallpox was like chickenpox, though. Once you got it, you couldn't get it again. This wasn't the only virus that presented all of these symptoms, as cowpox would soon spread around England and change the medical world forever. Through research and development, scientists found out about a sister virus to smallpox called cowpox. Cowpox was very similar to smallpox, mirroring many of the symptoms with milder consequences and a lower death rate. It came from European cows and was typically spread from milkmaids through sores on the cow's nipples. Cowpox originates from a virus known as the grease. Humans that tend to horses would often spread this virus to cows, since humans can carry the virus but not be affected by it. This is when the grease turns into cowpox. Cowpox is an unpleasant virus which mimics smallpox in appearance and symptoms. Typically, cows affected by cowpox don't produce as much milk as a generally healthy cow would. For humans, the symptoms of cowpox were very similar to those of smallpox, with a fever, loss of energy, sore muscles, vomiting, and headaches, but the general timeline for cowpox compared to smallpox was much faster. Symptoms would only be present for 1 to 3 days on average, seldom 4. The sores that came from the virus would heal very slowly, but would leave less prominent scars. Overall, cowpox was no fun, but it was a walk in the park compared to smallpox. In the late 1700s, a British doctor named Edward Jenner invented a safer vaccine than what they had been doing, giving people smallpox from ground-up scabs that were snorted or injected. He learned from a milkmaid that she had cowpox in the past and was now immune to getting smallpox. Astounded, Jenner began to conduct an experiment to test her claim. He took pus from the hand of a milkmaid infected with cowpox and put it into the arm of a young boy. The boy reported seeing a few pustules but had no further symptoms. 6 weeks later, the boy was variolated, which was the term for the vaccination method of choice prior to the experiment, but had no symptoms or pustules that resulted. This sparked interest in Jenner because if everybody had the results that this little boy had, then that would mean that once you get cowpox, you couldn't get smallpox. Jenner called this revelation vaccination after the Latin name for cowpox, variolae vaccinae. In the 3 years to follow, well over 100,000 British people were vaccinated using the scabs of cowpox victims. This was a remarkable breakthrough for medicine, but proved problematic because it was hard to get vaccinations all around the world since cowpox was a strictly British virus. This theory of the link between smallpox and cowpox was proven during a study done in the late 1790s. Joseph Merritt was a servant on a farm in 1770. On occasion, he would milk his master's cows, as well as tend to his horses. What Merritt didn't know was that he was transferring the grease from horses to cows, giving them cowpox, then contracting cowpox himself. He noticed some sores on his hands and was sick for a few days, bedridden and unable to work. 25 years later, in 1795, Merritt was vaccinated along with his family. While his family reacted normally with some of the symptoms of smallpox, he remained perfectly healthy and unaffected. In 1803, King Carlos of Spain was desperate to rid the world of smallpox for good, so he came up with a solution to this problem. Carlos loaded up his ship with 20 orphans, only one of whom was vaccinated. 8 days later, the orphan got pustules and scabs, which were then used to vaccinate the other orphans on the ship. This expedition went through the Americas and Asia to deliver the orphan scabs to people as a vaccination. This was generally successful, but it was still difficult to get the ship with the scabs everywhere. The world needed a way to cure smallpox everywhere before the world was entirely inhabited by smallpox victims.
The eradication of smallpox was a major accomplishment for doctors worldwide, as well as for human civilization. Cases of smallpox were spread out through countries until the last case ended in 1977, recorded in Ethiopia. In 1980, the epidemic was officially declared to have been eradicated. When smallpox was eradicated, a huge relief was lifted off the world's shoulders. With the help of the World Health Organization to prevent smallpox, they destroyed all labs filled with test tubes with the pox in Russia and also the United States. Since scientists had studied these samples before they were destroyed, they now know the full genetic sequence. Scientists will be able to create new viruses from smallpox to test out different types of medicines that can cure similar illnesses like this one. When scientists were able to stop the outbreak of smallpox, they soon shut down labs to not have to vaccinate many. They did this by quarantining people who already had the virus. They did this for many years so that they could prevent it from spreading to other people, instead of running around and vaccinating people. Taking the vaccinations weren't that easy. Relying on the long, sharp needles that can give the vaccine was better than using syringes that were previously in use from other people who are also in the process of becoming healthy again. Knowing that contagious virus would soon be out of their way gave hope to the world again that the horrible mass-killing virus can be cured with the right resources given. Soon after the eradication of smallpox, scientists had a scare that it may come back, giving people warnings to be careful around other people.
In the 1990s, Soviet defectors revealed that their government had actually set up labs to produce and weaponize smallpox virus that could be loaded into missiles and launched at enemy targets. Said Zimmer, this was a way for Russia to use a deadly weapon that nobody else had. This lab was soon destroyed, but the virus that they had stored in their lab helped scientists research an effective vaccination to end smallpox once and for all.